All right, so today's lesson is 6.3, and there are two main topics that we're going to do today. The first one, we're going to look at increasing and decreasing intervals, and the other thing we're going to do is domain and range. So what does the word increase mean? Go up. What does the word decrease mean? Go down. So we're going to be looking where the graph goes up and where the graph goes down. That's what increasing and increasing intervals are. When we are looking at the graph, we always read or always look at the graph left to right. So I want you to take your two colors here on the side and mark one of them as increasing and the other one as decreasing. Now this graph actually is a little bit different than most of the graphs we're going to be doing. We're not going to see any straight lines or any harsh points. They're going to be kind of curves, but you'll get the idea from this. So when we are looking at these intervals, we need to identify these main points, which we learned yesterday and the day before are the max and min points. So what is the coordinate for this point right here? -3, 3. And so write that on there, -3, 3, just with your pen, pencil, whatever. What is this one? 2, 3. And then the other one? 3, 6. Then looking over here, are these points, what are they? And what do the arrows mean? It never stops. So it like keeps going forever, right? Like off the graph. And that'll be important. When we are writing the intervals, here's what it's going to look like. We're going to have a parenthesis, and we're going to put the starting x, that's important, and the ending x. So we're going to have two numbers in parentheses. This does not mean it's a point. It's what we call an interval. When we are doing increasing and decreasing, you only write the x values of the points, of these max and min points. The y values aren't important. Now, sometimes you won't have a starting point because you'll start at an arrow. So if you have an arrow on the left, a left arrow, we're going to write negative infinity because we don't actually know what that number would be because it's not an actual point. So if the arrow is on the left side, it doesn't matter if it's pointing up or down. If it's on the left side, we put negative infinity. And if it's on the right side, we put positive infinity. Dang, that was a really bad infinity sum. Some people turn their page sideways and draw an 8. So let's look at this graph. We're going to write out the intervals. So starting at the far left, this is my starting point. If I were to trace this graph, am I going up or am I going down? Going up. So this would be an increasing interval. Do I have any more increasing intervals? Yeah, we're at. Yep, from 2, 3 to 3, 6. Good. What about decreasing? How many decreasing intervals do I have? Just one, this one over here. It's not increasing or decreasing. You actually won't, with any of the examples we do in here, you actually won't do that at all. You won't see any of those, but I wanted to throw that in there. So when it comes to writing the intervals, increasing, decreasing. So I'm going to start with my increasing, which was my pink, decreasing was my green. So I'm actually going to have two intervals, two things in parentheses listed. So my first one, where does it start? What did we say about this over here? It's an arrow. It goes forever, so we really can't find a start. Just because my arrow stopped there, that's not really where the whole graph started. So what do we do if we have an arrow on the graph? It's going to be one of these. And it's on the left side. So I'm going to say that it starts increasing at negative infinity. Because I don't actually have that starting x, because there's no way to pinpoint it because it goes forever. And if it's on the left side, it's negative infinity. Because if you look at your x's here, the left side, the numbers are negative. Where does this increasing interval stop? At the point negative 3, 3. Do I put both of those numbers? No, we only put the x. So in these increasing and decreasing, you only put the x. So it stops. What is the x value here? Negative 3. So my starting point for increasing, we really couldn't pinpoint an actual spot. So I said negative infinity, and then it stops at negative 3. I have another increasing interval right here. Where does this one start? Do I put both of those numbers? Just the 2. So it starts at 2 and it ends at, nope, 3. You're ending x. Starting x, ending x. So we only use the x values. That's all for increasing. Yes. Because it's an arrow. Yeah, because, I mean, it might look like it stops there, but that arrow really means it goes off. That's just where on the picture I had to put the arrow. Yep, so if you have an arrow on the left side, it would get negative infinity. If it happened to be on the right side, you would put a positive infinity. So here's for my decreasing. Where does it start decreasing? At 3. The x value is 3. Where does it stop decreasing? Positive or negative? Positive infinity, because it's on the right side. Yeah, it looks like it stops right there, but that arrow means it really goes on forever. So you would not, if I was rolling a marble here, if I let a marble go, that marble would go forever, because this is a downward ramp that would go forever to infinity. And that's all you do on those. The biggest mistake that people make is they forget to put only the x values. So you have to be careful. So let's go to some examples, more like what you'll see throughout this unit. And let's look at number 1. And what I did was I already have the graph here, but I want you to still find these points and using your calculator, because most of the time these points are not going to be exact points. They're going to be decimals. So we are going to find the max and min of these graphs. If we go to y equals, we'll type in x cubed plus 9x squared plus 24x plus 18. And then hit graph. Make sure it matches your picture. And then how do we actually go about finding these 2 points? What button do I hit? Trace. Right. So look down at your point. Mine right now has my point on 0 as my x value, 18. So if I go left, it's going to bring it down. Yep. Yeah, but that'll happen occasionally. So this is the point right here. Negative 3.94, 1.99. That would be rounding. If you're going to 2 decimal places. I'm a little lenient. If you put 2 there, that would be okay. But if, I'm trying to stay consistent with rounding to 2 decimal places. So at 2 decimal places, that would be 0.99. And I do want you to always be in the habit of putting those points and writing the coordinates on the graph. It makes it easier. And then if we go to this, the minimum, this one would be negative 1.97, and that one would round to negative 2, because that would be negative 1.997. That 7 would make it the 9s go up. So, and then I want you to take your colored pencil and I want you to mark all of the increasing and decreasing intervals. So just kind of trace over where it's increasing and decreasing. Try to use the same colors consistently. Yes. And if you look, these are not points down at the bottom. They're arrows. And then up here at the top. So we have 2 intervals of increasing and 1 interval of decreasing. So where do I start increasing? This first one. Where do I start? Negative infinity. If you look at the far left over here, go over down as far, there's an arrow, and that's on the left side of the graph. Where does it stop increasing? Yes. What about the other increasing interval? Where does it start? Negative 1.97. Where does it stop? Positive infinity. Well, even though I'm not meaning it's on the left side of the y-axis, but if you look at the graph as a whole, just the shape of the graph, it's on the right side of it. So it's not like, here's your y-axis. It's not because it falls on the left side of the y-axis. It's because of the graph. If I draw a line down the middle of the graph, it's the right side of the graph. And don't get confused and say that it's positive infinity because it's pointing up. Be careful, because it could still point up on the left side. If it's pointing up on the left side, it would be negative infinity still. So increasing, decreasing is thinking about left and right. So the decreasing interval, where does it start? Negative 3.94. And where does it stop? Negative 1.97. Good. Are there any questions? Let's go to number 2. Go to your y equals and type in this graph. Once you have it graphed, hit the trace button and go get your max and min points. So this first one here on the left is negative 2.27. And then for the x value, and then the y value is negative 1.51. I know it's kind of hard to see what you're writing and to get it all to fit in there, but do the best you can. Might even need to go sideways. Right that way.
That's negative
1.51. Yep. So then we go up to the maximum.
Wait, how are you making it hook onto that thing?
You hit the trace button. Yep, and that'll make it follow that exact graph. So I'm going to go sideways. Negative 0.76, comma 2.07. So that was my X and Y. You need to know how to get that on your calculator. And if I go on over to this minimum, so this is the lowest. Now you might see 001 and be like, oh, that's it. But if I go over one more click, 0.93 is actually lower than 1. So that's going to be that. 0.15, comma, 0.93. Thank you. And then once you get those points drawn in, trace over your increasing and decreasing. So we have, on this one, there are 2 increasing and 2 decreasing. So on my first increasing, where does it start? Good. Negative 2.27. Oops. You only put the x value. Where does it stop? Negative 0.76. Good. What about the other increasing interval? So this one, where does it start? 0.15. And where does it stop? Positive infinity, because it's on the right side of the graph. Try the decreasing interval. All right, decreasing, your first one should be negative infinity to negative 2.27. We use negative infinity because it's on the left. Yes, I know it points up, but that's not what we're looking at. It's on the left. And then the other decreasing starts at negative 0.76, and then it ends at 0.15. Are there any questions?